All right. Great. So let's kick it off. Hi, everyone. Thanks for joining our Open Fika number 9. So we're down to the 9th one here in the Corona times, and we're happy that you choose to join us here for a cup of coffee and a conversation. Today we will talk about smart battery management, and with me I have Rikard König, who's our CTO, and I'm Anders Alneng, and I'm co-founder with Rikard and VP of Sales. So before we get going, some rules of engagement. You have been here before, will notice that they are the same as before. So if you have any practical questions, something not functioning, sound or whatever, then use the chat function, and Elinor in the background will help you out with any eventualities. If you have any questions to me or Rikard, then you can use the Q&A function. And if you want the mic and comment, which we hope you will, then just wave your hand in the Zoom application. Right now, for the next about 15 minutes, everyone will be on mute, but afterwards we can open the mic. So without further ado, let's get started. When we talk about battery management, it's hard to do that without starting from electrification. Electrification, as you all know, is something that's been going on for quite a while, actually from the end of the 19th century, so it's nothing new. But what's happening is that you then change electricity as an energy source from an earlier power source that you had. And a lot of times this earlier power source is some sort of fossil fuel, and you change that to energy through batteries. And this means that electrification through batteries has a substantial impact on sustainability, and that is across the board. Really everything changed within batteries back in 1991, so that's about 30 years ago, when our friends in Japan, Sony, invented the first lithium-ion battery. And if you want to know more about IoT in Japan, then I can refer you to our Open Fika number 5, which is where we talk with our partner in Japan. But I would say that an even greater change has occurred during the last 10 years. We've gone from using batteries in smaller devices, such as mobile phones, cameras, flashes, etc., to actually be able to use them in larger devices, everything from automotors to cars to trucks to what have you. And there's also been quite a change in the electricity power grid sector, because being able to store energy means that you more and more can get away from needing to have a balance between supply and demand in the power grid. So this will also have an effect on households and industry. Now, what's been driving this change is the increase in where the price of per kilowatt hour on the batteries has substantially been lowered, and at the same time, in parallel, the energy density on these batteries has increased exponentially at the same time, which means that we can actually use them in applications as the ones I mentioned before. And if you look to the International Energy Agency, they predict that we will have in about 10 years' time 130 million electric vehicles. That's amazing. And that's coming from 2 years ago, 2018, about 5.2 million. So the change is drastic. If we now look at typical use cases when it comes to BMS, that's almost always evolved around 2 items. One is health, and the other one is range. Health has to do more with the inner of the batteries, where you look at load balancing, voltage predictions, etc., while range is more on the outside. So predicting battery life, remaining range, predicting remaining useful life or charging cycles, and also a lot about smart charging. So specifically, when you look at BMS on IoT devices, there are a few, I would say, challenges. One is that most of these IoT devices are mobile, and the usage of them vary quite a lot between device, and the charging patterns are completely individual for each battery. And also the information you can get out of the batteries are often sensitive information, personal sensitive information, which are regulated through, in Sweden, IPDR, but in other countries through other regulations. So these are some of the hurdles that you have to go and get over. And if you look at what we do at Ekkono Solutions, we do edge machine learning. And there's a lot of reason why edge machine learning is interesting and good, and specifically in battery management. You have everything from the data volume, the good data, the latency, but specifically, and what you will hear more and more about in this conversation, is connectivity, data integrity, as I mentioned before, and personalization. How can we make the batteries more context aware? And with me today, as I said before, I have Rikard König, and he will talk to you a bit more how edge machine learning can be applied to battery management specifically.
Thank you, Anders. Yes, if you look at the typical methods for performing battery management systems today, it's typically based on column counting, actually a detailed inspection of what currents go in and out of the battery. There are also voltage methods that you check on a controlled discharge to estimate the voltage and then the health of the battery, for example. You also use Kalman filter, which is a recursive technique to actually get an error bound and to continuously update your model. And that is based on a model of your battery. And these techniques are struggling a little bit in this scenario with the IoT devices, which has a very varying environment, varying usage patterns, and so on. So that's why we're starting to look at machine learning. Machine learning is, you can see it as an extension of Kalman filter, which facilitates even more complex modeling. But the basic is that you look at the voltage, the current, and the temperature of the battery cells and try to do these kinds of predictions that Anders was talking about. What is the health of the battery? What is the remaining useful life? How long can I use the battery before it needs to be recharged? Or how long can I get on the battery? And this is what we're going to look at, but in the context then of machine learning. We should also say that Ekkono is not an expert in battery or even battery management. We are providing a software library for edge machine learning that can be used in these circumstances. And here, in the cases we've been working with battery management system, we've been working with domain experts, so it's giving us that knowledge. But we won't go into too much details today anyhow, so I hope you will find it interesting. So first, looking at IoT devices, they have such a varying usage. And if you take an electrical vehicle, like a car, the battery usage and the consumption and everything will vary a lot if it's driving in north of Sweden or even just south of Sweden, because I mean the temperature has a very strong effect on the battery's charging and discharging capacity. And how you use the battery affects the remaining useful life, how it loses capacity over time. And it's connected to how each unit is used. How often is it charged? How is it charged? What kind of ambient temperature is it exposed of? High temperature is never good for a battery, for example. So it's rather important to be able to do one model per device, since a general model will have hard to adapt to all the changes, all the variations. It's not impossible, but it's much easier to get more specific and be more accurate if you do one model per device. And to do that, you really need to use machine learning, and a specific, if you want to do it on the edge, you need to use incremental learning, which is one of Ekkono's specialty, that you're actually learning on the device and adapting the model as you go along. And if you do that, you can do you can start with a generic model, and you have an estimation that this one will have this lifetime pattern. But as you can observe more and more data from more and more charging cycles, you can actually learn how the user is using this battery and how it's affecting the remaining useful for life and the charging capacity. So you will be able, if you can adapt your model, you can actually get a closer and closer estimation of the real remaining useful life. And this is hard to do otherwise, since a battery, especially in an electrical vehicle and most vehicles, are designed to last many, many years. And it's hard then to be able to account for all the variation and collect data for several years. You end up trying to do simulated experiments, which doesn't then account for the real world, really. But by applying machine learning and actually observing the battery in use, you can adapt your model and adapt your guesses as you go along. You can, of course, go down to the more specific things, like in the traditional BMS system. You can try to predict how much current you can deliver at different state of charge and the voltage that you have. Of course, the current and the voltages are very highly connected since they relate to the power outtake. And here you have it's a mature field, and you have this traditional method that works rather good for the general case, but it can be complicated, and we strongly believe that it can help to use machine learning, and especially incremental machine learning, to do them even better by tailoring these models to each device. But when we say smart battery management, we don't only look just inside the battery. We like to include the device itself, because what you connect to the battery, of course, will affect the battery, how it's used and how it's charged and discharged. And for some, like power tools, you may have the same battery for different types of machines. And then they have different usage pattern and that you need to account for. And then, of course, you have the user themselves. If you have a human, if it's not a fully automated device, you have the human aspect and how it's actually used. And by modeling the user, you can actually make assumption of how he will continue to use it. And then you can do better, for example, range prediction or battery life. How long time can I use my leaf blower or whatever it is that I'm using at the moment. And then finally, we also look at if you can model the machine and the user in a good way, then you can look into the future. Do we know anything of the user's plans? For example, the GPS route or how his work shift or so on. And we can include all these things in our battery management system to get better prediction. I will show you some examples of each here to see how it all comes together, really. So start with looking at how we can model the user. And I have this a little bit complicated diagram, but I will explain it for you. The y-axis says exactly how much current, how much charge you have left in your battery. And it goes down depending on the power outtake, which is the blue one here, like this. And we would like to predict, typically often, we would like to know how long can I use this device. It can be range if it's a vehicle, or it can be time. So you would have time or distance here. And if you would just look at one moment in time and say that, okay, I think that the user will continue to use the machine that is doing exactly now. Then in this case, we would predict that the battery will be out at this point. While just a bit later, while he's maybe idling or using it in low power mode, we would get a very different prediction. So either we would vary a lot, or we would be constrained to just guessing it will last as long as it did last time. But if we instead model and learn from how the user typically use the machine, and you can do this in different ways, and I won't have time to go into that today, but then you can actually make a smarter estimation of that he will continue using the battery that is like he's usually doing, or the machine then. And then you can get a better estimate of the remaining range or the remaining time you have in the battery. So this is one way, by modeling the user's actions with the machine. Sometimes the machine itself or the device is rather complex, so it's not given what is exactly affecting the power outtake. If you take an electrical vehicle, for example, of course you have the throttle and the speed, and then you brake sometimes, and then you actually generate electricity and charge the battery. You have the inclination when you're driving, and the temperature, of course, which will affect both the battery if it's not have a controlled heating system for the battery itself, but also the climate system, which is a large power consumer in electrical vehicles, to either heat or cool the car. And then, of course, you have the weight. So if you can learn the relation between all these factors, like temperature, as soon as you put temperature in the game, your model needs to be very much more complex to be handling how is the battery discharging at different state of charge and temperature, right? But then you can see how it will be if you add more and more variables. And this is very complex for traditional techniques, but it's a great case for machine learning, and especially for incremental learning, since you can do one model for each machine as well. So in the end here, what you get is a very good decision support that you can connect to your battery management system. So if you can model the actual power outtake of your vehicle and its environment's effect on the power outtake, you can, for example, do simulation and give the user a good decision support. So at any given point in time, you can tell the user that, well, first, if you have modeled the user's behavior, it will say that if you continue using the machine as you usually do, you will have 10 minutes of time left with the machine. But if you switch to power mode to get some extra power in whatever you're doing, then you will lose 5 minutes. But if you instead increase or switch to the eco mode, you will get another 10 minutes. So you would actually maybe able to last and use the tool all the way until your shift ends, or until you have a break and can go and change battery. So it can be a good way to actually empower the user to use the tools better and smarter. If you put all this together, that we have modeled the vehicle, and we have modeled the user, and we have a model of the battery and how that works for different temperature and stuff like that, we can put it together and actually do much more accurate range predictions. Since if we put in a GPS route in the car, we will know exactly how the inclination of the road to where you want to go. You can look at the weather forecast, and they are really normally very accurate, at least in the temperature for the coming hours, which would be relevant here. And you can see here, this is just a forecast for Kiruna, I think, in Sweden, and for today actually. And in just a few hours, you can have a 10 degrees difference, and that will affect your battery. And you could even add then traffic information if you're driving somewhere and you know that, okay, you're going to be stuck in traffic here for half an hour at some point. All this you can actually feed into these three models and simulate and get a much more accurate prediction of what you do. And this is not just for electrical vehicles. It's whatever, if it's a power tool or if it's a drone or whatever, you can apply this kind of modeling. And it's really to add the information about the user and the environment, and doing the incremental model, having one model per device that is really enabling all this functionality. So to draw some conclusion of that, or what we want to point out here, is that we think that the battery management system for IoT devices must be able to account for variations in use and environment, because there will be a lot of variation in those aspects. And we also think that the smart BMS system should be extended really to include both the machine and the user when applicable. And by applying edge machine learning, we actually can do that, and it will help the batteries to be self-learning, to adapt to the environment and be aware of the environment as well. So you can get a model that is not just constant, but is actually adapting and learning as you go along and becomes better and better. And this also facilitates the operator or driver to adapt and to optimize his own behavior and the use of the machine if you want that. And you will have better range predictions by considering not only the battery, but also the user and the knowledge about future plans and events, really. And this also, if you think about it, it also enables smart charging. If you know what's going to happen and how it's used, you can charge it just enough if you have a short charging time. How much do I really need to charge to get to my final destination? So, and that was the end of this part.
Yeah. We have questions, so I'll read them out and see who's best equipped to answer them. The first one is how battery management with edge machine learning can contribute to the circular economy. I'll take a stab at that. I think that with edge knowledge and specifically being context aware, understanding what has happened to the battery during its whole life cycle, really helps to contribute a lot to information that is important for the circular economy. So I think edge machine learning with incremental learning, understanding the battery is valid for that. Do you want to add something on that?
Yeah, I can just add, like, for example, you can see that one battery that is no longer powerful enough to be used in one power tool could be well worth for another not as powerful and can be used maybe a year or half a year extra for that. That's a way that you can extend the life and actually reuse the parts as well.
And use the batteries to the very end. Yeah, that's good. The next one is where is battery management preferably run, on the actual battery or on the electrical driven component?
Well, if I would say that if you have, you would probably have, it's a good question. It depends what you want to achieve. If you have a battery that is, you can move around, you would like to have it on the battery, right? But if it's fixed, I would say we'll probably have more resources and be able to do more advanced modeling on the device itself if you have a small CPU there.
And then we have a question here from Anna Karin. Do you have any experience using the charger as an IoT device instead of the actual battery?
No, so far it's an interesting idea actually to do it, and it could probably be done as well. You would like to maybe have some ID and to able to recognize the batteries. But yeah, I mean, we often work with gateways which collects data from different devices, and if you have a charger that charge different devices, you can compare it to the gateway as well. So you can definitely put some intelligence there as well, if you like to.
Could be the charger as a sensor or something like that.
Yeah.
And then what is the challenge of actually deploying a smart BMS on the IoT device?
Yeah, I would say that, of course, I mean, the first that comes into mind is the resources. I mean, if you want to do first, if you want to do some modeling, you don't want to use too much energy, because then you will reduce the life just by doing the modeling, and you don't want to do that. So the model itself needs to be tiny, and the program around it and the library that you actually deploy needs to be has a small footprint as possible, and should be really fit. Usually you need to also have, like, it's written in C and a very low level language to make it work. So I think that's the resources, and maybe also the update to be able to, if you want to change model or something like that. But that also helps. If you have an incremental learning, the model can more or less update itself over time as well.
Good. I don't see any more questions right now. So maybe we can move on. So since battery management has a lot to do with sustainability, it ties in really well to the next Open Fika that we'll have the 17th of June, which will be led by John Linden, our CEO. And then we'll have last, not a last, but last before vacation Open Fika. And there John will give some tips and hints about how we hit the ground running in a more post-COVID world, which we all hope will be the case when we sort of get out of the vacation mode. So that's that. And then obviously we are on all social media, so please follow us there. I'm sure that some of you got notification about the event on a LinkedIn or a Facebook, so keep on doing thumbs up on those platforms. And we'll continue. We'll have 2 more before the vacation, and it's quite probable that we will have more than once people are back from vacation. So if there's nothing else, then I think we'll say thank you from our side.
Thank you everyone for listening.
Thanks all. Cheers.
Cheers.